So the first step of finding the GCF is to look at the numbers that they give you or look at the problem that they give you and find the biggest number that goes into both terms. Now, the ones that I'm doing are in the book on page 390, and I'm working off of the second column down. So I'm going to start at number 2, then go to number 5, then go to number 8, all the way down to 17 so that you can see a flow for how to do this. Sometimes we know our times tables really well and we can pick our GCF out right away. But again, we're looking for the biggest number that divides into both terms. If you don't know your GCF right off the bat, and you don't want to guess, because what that does is that takes longer to actually do, you take the smaller number and you write the factors out. So my smaller number is 60. So I know that my factors are 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. That's all of them. And then what I would do is I'd start with the biggest number and take 75 and divide it by 60. That does not work. 75 divided by 30 does not work. 75 divided by 20 does not work. But 75 divided by 15 does work. So 15 is the biggest number that divides both into 60 and into 75. Again, if you write all the factors down of the smaller one and then start from the highest number and divide it to see if it works. Now, if it works, you won't have a decimal. This is a decimal, so this is a no. 75 divided by 30 is a decimal, so that's a no. And by the time you get to 15, what is that, 15 times 5? So because 75 divided by 15 is 5, that means that 15 is a common factor, and it's the biggest one that works. Now, does 5 go into 60 and also into 75? Yes, but it's not the biggest one. And this is how you find the biggest one. We're going to move to number 5 now. Number 5 gives us 3 terms. It gives us 8, 15, and 40. Now, the trick of the trade is to go with the smaller number and write the factors out for the smaller number because it'll be easier to manage. As far as this is concerned, the biggest number for factors for 8 is 8. Well, does 15 divide by 8? No. So if 15 does divide by 8, then it doesn't matter because it has to work for all of them. Does 15 divide by 4? No. So that means that it's not going to work for all of them. And does 15 divide by 2 evenly? No. So the only one that works for this specific problem where all 3 factors, the biggest one that goes into it is 1. That's the GCF. Number 8 is a little different animal. For number 8, we have x squared and we have 5x. And what we do for variables is we look for what is the number of variables that all of the terms can afford to give. Now remember that x squared means x times x, and 5x is 5 times x. So that means that they literally only have the opportunity to give 1 each. Essentially, you pick the lower exponent one. So that's this one. So x is our GCF because each term can only give 1 x away equally. Let's take a look at number 11. Number 11 is the first one that has both the numbers and the variables in it. Number 11 has 2x squared and a 2x and a negative 8. Now, as far as GCFs go, the smaller one is 2. So 1 times 2 is the factors. And of course, you should know that 2 divides into 2, 2 divides into 2, and 8 divides by 2. So 2 is our GCF for the numbers. When it comes to the variables, I've got 2 x squared here. So there's 2 x's here. There's one x here, but there's no x's here. So they all can't equally give any. And because not all of them have it, then you can't use a variable at all. So the GCF of this one is simply 2. You can't use the x's because this doesn't have one to give, and you have to give variables equally throughout all of the terms. 14 is a big one. Let's look at 14. Ooh, it is a big one. 16 p to the 6th q to the 4th. 32 p to the 3rd q to the 3rd. And negative 48 p q squared. So I'm just going to go through and make sure that I wrote that correctly. 16 p to the 6th q to the 4th, 32 p to the 3rd q to the 3rd, and negative 48 p q squared. That's correct. Okay. So the smaller number that we're going to write factors for, 16. So 1 times 16, 2 times 8, 4 times 4. So we're going to start with 16. Does 32 divide by 16? Yes, 32 divided by 16 is 2, so that works. Does 48 divide by 16? Well, 48 divided by 16 is 3, so that works. So 16 is the biggest number that divides into all 3 of these. So 16 starts out our GCF. Now we look at the variables. This says that we have 6 p's, this says we have 3 p's, and this says we have 1 p. So if everybody's giving equal amounts of p, the smallest exponent is p to the 1st. So that would be your part of your GCF. Now we're looking at q's. We've got 4 q's, 3 q's, and 2 q's. So again, if we're giving away equal amounts, then we have to go with the smallest amount, which is q squared. So your GCF for number 14 is 16 p to the 1st q squared. I got one more for you as a practice, and then we'll move on to the next one. This is number 17. And 17 says x to the 5th, y to the 5th, x to the 4th, y to the 3rd, x to the 3rd, y to the 3rd, and negative x squared y squared. And our job is to find the GCF. Now, this one doesn't have any numbers in it, like big numbers, coefficients. All it has is exponents. So we're typically just looking at, does all of them have an x though? I got an x here, x here, x here, x here. Good. So then the lowest exponent that everybody can afford to give is x squared. And the lowest y, of y to the 5th, y to the 3rd, y to the 3rd, y squared, is y squared. And there's your GCF for that. So hopefully this helps you to understand how to find GCF. Again, you're looking for the biggest number that divides into all the terms. And we do that by taking the lowest factor, and we write all the factors out. We start with the biggest one, and we divide them all through and see if it works. Then you look at the variables, and as long as they all have the same variable type, you pick the lowest exponent for that.